All right, today we're moving on to our next lesson in our statistics unit, which is called Measures of Center. This goes with digits 15.1. So in your table of contents, write the title of the lesson, Measures of Center, and then the EQ for today, you need to set up your next page in your spiral notebook, title at the top, Measures of Center, and then the essential question for today, how can I use measures of center to make inferences about a population? Hit pause and set up your notes. When you're ready to move on, hit play. All right, we have a couple of definitions that you need to know, and then we're going to practice how to find each of these different measures of center. The first one is the mean. You may or may not have heard of finding the mean of a set of data before. Copy this definition into your notes. What is the mean of a set of data? It is the sum of the data values divided by the number of data values. So you're going to take your calculator and you are going to add up all the numbers in your data set. Okay, so the sum means we're adding. You add up all the numbers in your data set. So you can see here they've taken this, they've added up all the numbers, and they got 28. Okay, then we are going to divide, that's why it's written as a fraction, because it's division. We're going to divide by how many numbers are in our data set. So I count 1, 2, 3, 4, 5, 6, 7. There's 7 numbers in my data set, so I divide by 7. So I would do 28 divided by 7, which is 4. Okay, so finding the mean, you add up all the numbers in your data set, you divide by however many numbers are in the data set, and that is your mean. It is a measure of center. It's helping us find kind of the central number of the data set. The next measure of center you need to know is median. When we're doing the median, it is the middle number of the data set. Okay, and there's two different things that you need to know for finding the median, depending on if there's an odd number of data values or an even number of data values. So I want you to copy both of these things down. Okay, so the median is the middle number in your data set when you put your numbers in order from least to greatest. It's the middle number. When you have an odd number of data values, you're just going to get one number in the middle. The median is the middle value where the data values are arranged in numerical order. That means from least to greatest. But when we have an even number of data values, when you're starting at the outside and kind of crossing out to get to the middle number, you're actually going to get two numbers in the middle. Like right here, we would cross out -5 and 9. We would cross out -1 and 8. We would cross out 3 and 8, and we would find in the middle of our data set, trying to find the middle number, that there's actually 2. When that happens, you're going to add those two numbers together and then divide it by 2. So whenever you get two numbers in the middle, add them and divide it by 2. Okay. If you have an odd number of numbers in your data set, you're going to cross out the 2 outside numbers, cross out the next ones, cross out the next ones, and you just get one number in the middle. That number is your median. But if you have two numbers in the middle, you add them and divide by 2. This is called the median. Okay? Okay, here, this is going to be example 1 in our notes. And you may or may not have seen this before. This is called a dot plot. We see a number line, and it has dots on it. So the number line is going to tell us what these numbers are in our data set. Each time we have a dot, that is one time that number occurs in our data set. So I see that this number line is going from 5 to 10, so I know that this is 6, 7, 8, 9, 10. And on state testing, on map testing, they love to give you questions that have these dot plots. So make sure you understand how I'm going to get the numbers from this dot plot. So my first dot on my dot plot is right here. It's halfway between 5 and 6. So what number would be halfway between 5 and 6? It would be 5.5. I want you to write this list of numbers that I'm going to write down. Write this in your notes. This is example 1. Okay? All right, 5.5. My next number in my data set is 6. My next number, I see 2 dots at 7. Okay, so I'm going to list the number 7 twice in my data set. Next, I have a dot at 8. Next, I have a dot halfway between 8 and 9. That would be 8.5. And then I have 2 dots at 10. So I'm going to list 10 twice. All right, make sure that your data set is exactly like mine. Right here, I have my data set. And then for part A, they've asked us to find the mean and the median. The are going to do 5.5 plus 6 plus 7 plus 7 plus 8 plus 8.5 plus 10 plus 10. And that gave me 62. So I added all of these numbers together, and it gave me 62. Now I have to divide by the number of numbers in my data set. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers in my data set. So I'm going to do 62 divided by 8. Okay, and when I punch that in the calculator, 62 divided by 8 gives me 7.75. So the mean of my data set is 7.75. Okay? Next, they want me to find the median. Now remember, the median is the middle number of my data set when I put it in order from least to greatest. So the trick to doing this is you're going to, I like to take a color, or you can just use your fingers. We want to cross numbers out starting from the outside in, going toward the middle to find the middle number. So I'm going to cross out 5.5 and 10, then 6 and 10, then 7 and 8.5, and I get 2 numbers in the middle. I have 7 and 8 in the middle. Now remember what I said we do. When we have 2 numbers in the middle, I'm going to add those together and then divide by 2. So 7 plus 8 is 15. 15 divided by 2, in the calculator, that is 7.5. So my median is 7.5. Okay, and then the second part of this question says, using measures of center, which is this mean and this median, what inference can you make about how often the Joule geyser erupts? We would make the inference that it is going to be about every 7.75 to 7.5 minutes. Okay, so it's going to erupt about 7.5, maybe closer to 7.75 minutes. That's what we would use to make our prediction. Okay? All right, let's try one more. If you feel like you can do the mean on your own, go ahead and do it. If you want me to do it with you, you can just keep playing the video. All right, they've asked us to find the mean height of the geyser's eruption. What do we do first to find the mean? We have to add up all the numbers in our data set. So I'm going to take my calculator. 15 plus 30 plus 27 plus 23 plus 28 plus 19 plus 14 plus 11 plus 22. So that gave me 189. And we're calling this example 2. Okay? Everybody doing this with me? Now, for the mean, I add up all the numbers in my data set, then I divide by how many numbers are in my data set. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 numbers in my data set, so I divide by 9. So 189 divided by 9. So gives me 21. So my mean is about 21 feet. Okay, so I would expect the next geyser eruption to be about 21 feet high. All right, next thing to copy, hit pause and copy this down. You don't have to copy the little dot plots, but I do want you to copy this at the top. How can you use measures of center to compare data? So sometimes you'll just be given one data set, but then sometimes we'll have 2 separate data sets that we have to compare, okay? So we might need to find their means or their medians to compare the 2 data sets. We can compare their individual values. A quicker way to make a general comparison of 2 data sets is to compare their measures of center. So comparing their means or comparing their medians. In this example down here, they have found the means. Okay, Class M, this is talking about how many doodles they have in their notebook. They found for Class M, they had a mean of 4.05 doodles in their notebooks. In Class R, they have a mean of 5.1 doodles in their notebook. So to make an inference or a prediction about the classes, I would predict that Class R is going to have more doodles than Class M because the mean is bigger. All right, let's try this one. It says that we're finding the mean, and we're comparing the hyacinth macaw and the cockapoo, okay? I guess that's what, I thought a cockapoo was a duck, but whatever. Apparently it's a bird too. So we're going to compare, and this is example 3. So finding the mean for the hyacinth macaw, again, we add up all the values and then we divide by the number of values in the data set. So take your calculator, 2.8 plus 3.7 plus 3.9 plus 3 plus 3.1 plus 3.4 plus 2.9 plus 3.2. And that gave me a sum of 26 when I added all those up. And I have to divide by 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. Alright, so my mean for the McCall is going to be 3.25. This is talking about the weight, the pounds. So I would predict that another McCall would weigh about 3.25 pounds. Now let me find the mean of the cockapoo. If I'm saying that right. 3.9 plus 4.3. Sorry, 4. How I can't read. Plus 5.3 plus 6.7 plus 7.4 plus 8.1 plus 6.4 plus 8.1. So I got 50.4. Much bigger, I'm noticing. So then divide by, there's also 8 numbers in this data set. 50.4 divided by 8 gives me 6.3. So my mean weight for a cockapoo is 6.3 pounds. So if I was making a prediction about which bird is going to weigh more, which would I think is going to weigh more? The cockapoo, because its mean weight is bigger. Okay, last thing you need to know. Which of the different measures of center is going to be more helpful to us? It depends on the data set. If you have different comparative inferences based on each measure of center, you can draw a conclusion about the situation by looking more closely at the data sets. Sometimes we are going to have data sets where there's one number or a couple numbers that are way bigger or way smaller than the rest of the data set. Right here, we call these skew numbers, or they're stray data values. Whenever we have a number that's kind of separate from the group, like here we see that all of the data values are together, when all of them are together, we want to use the mean. But if we had a number that was way, way bigger than the other numbers, that would mess the mean up because we'd be adding all the numbers together and then dividing by the number of numbers. This would mess the mean up, so that's when we want to use the median. Okay, so looking at this example here, do I see my data sets being really close together, or do I see some stray values? Well, look at version A. I see right here that there are a couple points that are way, way far apart from the rest of the dots. So because of those stray values, I'm going to want to use the medians to compare my data sets. Okay, so looking at the medians, I see that version A of this book took 30 minutes to read 25 pages. Version B of this book took 30 minutes to read 23 pages. So my conclusion that I could make then, since I was able to read 2 more pages of version A, this book is probably a little bit easier to read. I only read 23 pages of version B, so this book probably takes a little bit longer per page to read since I didn't read as many pages. All right, at this point you should be ready to do digits 15.1, and there's also several IXLs that go with this, working with mean and median, your measures of center. If you need help, raise your hand, and let me check your notes when you're done with this.